Hello, good day. My name is Kisses Don Maxina Mogas, and I will be reporting about couples and its characteristics. Steering a wheel, turning the knob, and tightening a lug nut. What do you think all of these have in common? Well, they are all in a rotating motion, of course. Let's say there are two boys pushing a table with the same magnitude of force in opposite directions. The both of them are acting on the same line. So what happens is the table won't move because the forces were cancelled. But how about if the boys were not acting on the same line? What if they moved on the opposite sides of the table? If that's the case, then the table will rotate. In this scenario, a couple was established. Before we proceed, let's first define what a couple is. A couple is a pair of equal and opposite forces not acting along the same line. In other words, couples counteract each other in order not to cause imbalance in the body due to external forces acting on it. So basically, they are formed to maintain the body or object in an equilibrium state. Couples are classified into two categories based on how the rotation is applied on the object. First is a clockwise couple, where obviously they rotate in a clockwise manner. Then there's an anti-clockwise couple, in which the body rotates anti-clockwise. Take note that couple produces only rotation and no linear acceleration or linear motion. And don't be confused with couple and momentum. They are not the same. The moment of couple is defined as moment equals to force multiplied by the perpendicular distance. This one is in scalar analysis. Well, if we use vector analysis, we'll have moment equals to r multiplied by the force applied. Here, r is any position vector from the line of action of F. Let's move on to the properties of the couple. First, it has forces that are equal in magnitude and opposite in direction. Second, it acts along the parallel lines of action. Next, they are separated by a perpendicular distance. And lastly, the resultant force of a couple is zero, but the resultant moment is not zero. For example, in this image, the two forces resultant is zero because they are positive and negative forces, so they will be cancelled out. Let's have another example. The magnitude of a resultant is given by the summation of forces that is equal to negative 10 plus 20 plus 30 minus 40 equals to 0. But you should not assume that there is no resultant at all. Since on taking the moment sum at P, we will find this equation. The system shown therefore does produce some effect. In this case, there's a tendency to rotate with a magnitude of 60 feet-pounds. And here's the rest of the resultant forces at each point. As you can see, the resultant has the same clockwise moment effect regardless of where the moment center is chosen. Now, let's try to solve these simple problems. Two couples act on the beam with the geometry shown. This time, we should find the magnitude of F so that the resultant couple moment is 1.5 kN/meter clockwise. Now, what we have to do is add the two couples to find the resultant couple and equate the net moment to 1.5 kN/meter clockwise to find F. The net moment is equal to negative force times 0.9 plus 2 minus 0.3. This equates to negative 0.9 F plus 0.6. Substituting the value of moment, which is equal to 1.5 kilonewton meters, equals to negative 0.9 F plus 0.6. This equates to negative 1.5 minus 0.6, which is equal to negative 0.9 F. Negative 2.1 divided by negative 0.9 is equal to negative 0.9 F. Solving for the unknown force, we get F is equal to 2.33 kilonewtons. Next problem. Calculate the moment caused by force F about point A and point B. So first, we will calculate the moment caused by force using perpendicular distance. For moment about A, we have a perpendicular distance of 4 meters. Therefore, moment is equal to force multiplied by distance. So, 80 newtons times 4 meters is equal to 320 newton meter in clockwise direction, since it is positive. While in moment about B, we have a perpendicular distance of 1.5 meters. Therefore, we have 80 newtons multiplied by 1.5 meters. We get 120 newton meters, also in a clockwise rotation. That's it. This ends my report. Thank you for listening.